Hello and welcome. We're going to pull back the digital curtain a little bit today on something we all use constantly, but maybe don't stop to think about. What's really going on behind the scenes on the websites we visit every single day?
I mean, think about it. You type in a web address, you click a link, and poof, a page just appears. It feels like magic, doesn't it? But what is actually happening in those few seconds between your click and that page loading right on your screen?
Well, it turns out it's not magic at all. The simplest way to think about it is it's a conversation. A very, very fast and super structured conversation between your computer and another computer somewhere else in the world.
Okay, so let's dive into that a little deeper. To have any kind of conversation, right, you need at least two people, or in this case, two machines. In the world of the internet, we call them the client and the server. It's pretty straightforward, actually. The client is just your web browser. Think Firefox, Chrome, whatever you're using right now. It's the one asking for stuff. And the server, that's a big, powerful computer that's always on, and its whole job is basically to listen for those requests and serve up the information. It's a really simple and kind of beautiful relationship. Let's start with a basic web page, what we call a static page. The process here is a lot like checking a book out of a library. As you can see here, your browser, the client, makes a request. The server finds the exact file it's looking for on its hard drive and just sends a copy right back for your browser to display. It's a super clean, direct one-to-one exchange.
Okay, but this brings up a really important question. How does your browser, say here in the US, know how to talk to a server that might be all the way over in Japan? For any conversation to work, both sides have to agree on a common language and a set of rules.
And that right there is where protocols come into play. You can think of protocols as the grammar and the etiquette of the internet. They make sure that every single request and every single response is understood perfectly, no matter where in the world it's coming from or going to. This is just a brilliant analogy. Think about mailing a letter. The Postal Service has rules, right? You have to put it in an envelope, you have to write the address in a specific place, you need a stamp. The internet works the same way. It has its own set of rules for how to package up and send data. So that's what a protocol is officially. It's the rulebook for communication. It defines everything, how the messages are formatted, the order they get sent in, and even what to do when a message is received. It's this shared language that makes the whole global internet possible. Now, to keep all this from getting totally chaotic, these rules are organized into layers, where each layer has just one specific job to do. It's like a digital assembly line. Way up at the top, you've got the application layer, using HTTP to handle your web request. Underneath that, the transport layer, that's TCP, makes sure all the little packets of data arrive safely. And then the network layer acts kind of like that postal worker, slapping the correct to and from addresses on everything. Splitting up the work like this is what makes the whole system so strong and so scalable.
So this system we've talked about works perfectly for sending a simple file, but what happens when the page isn't just a file sitting on a disk somewhere? What about a page that's built specifically for you right in that moment, like your social media feed? This brings us to the really cool part, the dynamic engine that powers pretty much the entire modern web. The conversation suddenly gets a little more complex. We need a few more participants at the table to build these pages on the fly.
And this image illustrates the difference perfectly. Instead of a librarian just grabbing a book off a shelf, this is like walking into a restaurant and asking a chef to make you a custom meal. The request comes in, but instead of just grabbing a file, the server now has to actually do something. It has to cook. It uses a processor and a database to build a page completely from scratch.
The two key players in our kitchen here are tools like PHP and MySQL. Think of PHP as the chef. It's a programming language that lives on the server, and it follows a recipe, a set of instructions to assemble the web page. And MySQL? Well, that's the pantry. It's a database that stores all the raw ingredients, your user profile, your friends' posts, photos, comments, all of it.
So here's the crucial difference. For a dynamic website, the server isn't just a file clerk anymore. It's a workshop. It takes your request, it runs a program, it pulls fresh data from a database, and it generates a brand new personalized web page tailored just for you. And it does all of that in a fraction of a second. It's pretty amazing.
When you really step back and you look at the whole process, from that simple click all the way to a fully interactive page, what you see is an incredibly elegant and really well-designed system. So let's just do a quick recap. It all starts with a simple request from a client. Clients and servers talk to each other using a shared language of protocols.
These rules are organized into layers to keep things from getting too complex. And finally, while simple sites just send files, dynamic sites use powerful tools like PHP and MySQL to build brand new pages just for you on demand.
So the next time you're browsing a website, just for a second, remember what's happening underneath it all. It's not just code and circuits. It's this quiet, rapid, and beautifully structured conversation, an elegant dance of request and response that connects all of us.